Hello guys, my name is Diego Pacheco and this is another slidecast. Today I want to share some reflections and some thoughts about SCM, Software Configuration Management, or another way to put it, we're going to be talking about branches and architectural patterns, and we're going to be discussing options and also trade-offs, and we're also going to be deeply thinking about modules and the relation with CICD. So there's no right and wrong. There's definitely different schools of thought, right? And hopefully this will help you guys to navigate across the landscape. I personally more towards the CICD school, which means trunk-based development, but I did most of these modules, or basically all these modules I can say across my career. So without further ado, let's get started. Okay, so let's go there. So basically, we will be talking about reflections on SCM, right? So let's go there. So every company has branches, right? Nowadays, pretty much every company work with branches and pull requests. I can easily say that's the default standard that everybody is doing. Some companies do Git Flow more towards mobile, but I see people doing Git Flow outside of mobile. And few the great companies, they do trunk-based development, like Google, for instance. But people do branches, right? That's a fact. And I want to say that's sort of different ways to see branches, right? We can see branches as a different code path, right? And that can be done with code, all right? If you think about the if, that's a branch. If you think about object orientation and we think about polymorphism and overriding, we definitely have branches there, right? And the classical source code repository is also a way to deal with branches, right? So Git made branches much less painful. So before Git, working with branches was much more complicated and hard. So basically, the tooling evolved a lot, all right, and that made every developer life easier. That's a fact for sure. However, we need to think beyond branches, all right, and we need to think about what implications or branching approach or branching model has to do with the overall architecture, right, and the overall DevOps initiative, I would say. So we need to think about, okay, so how much branches can affect CI/CD? Are they good for CI/CD or are they bad for CI/CD? Something we need to think about it. How much branching can affect refactoring? Is branching allowing us to do more refactoring, or is branching actually making us doing less refactoring? That also something we need to think about it. We also need to think about bottlenecks, all right? Because in theory, branch can prevent bottlenecks, all right? Can bring stability, but actually can also do the opposite. It can bring instability and can create more bottlenecks, as you need to merge eventually everybody's code, and then we might see problems that before they were not appearing, right? So that's really holy wars there. That's a battleground about that. But that's something we definitely need to think about it, and especially think about the use cases we have, the teams we have, the kind of a software that we are building and where we want to be. So that's a very important reflection we need to have. We need to think about that. And I also would argue, right, that there's a lot of relation with architecture and architecture patterns. So how much branching hide the architecture complexity? Because a good architecture is modular. With modularization, with isolation, you actually have less common touching points. So by nature, a very well architectured software, you're gonna have less needs of doing branches, unless you have everybody touching all the time the same files, right? Which is like a hotspot. And I could argue that, why everybody needs to touch the same file over and over again, all right? So it really could be some complexity there or bad modularization. So we need to think about architecture, not only about branches, right? It's easy to just think about branches and forget that we might have architectural problem there, right? So branches can hide that because you feel protected on a branch, right? Or is the other way around, where actually you have a bad architecture, and I feel that happens a lot in mobile, all right? And the branching is actually helping you to navigate towards that complexity. But it's a very important key point that we think about it, okay? What's the relationship between branches and architectural complexity? And finally, we need to think about the model and what the model is optimized for, right? Because there's different optimizations, right? So is the model optimized for local, thin, collocated work? Is optimized for remote work, but is still the same thing, but sort of distributed, right? Is this work model optimized for local collocation, like you're doing pair programmings most of the times, or mod programming? Or what is optimized for open source and remote contributors that just contribute one time and you might never ever see these guys again, right? So we need to think about that considerations as well when we are embracing a branch model. And what happens in practice is people do not talk about these dimensions, do not talk about the effect it has on CICD, doesn't talk about the effect that it has on refactoring, doesn't talk about the bottlenecks that creates or removes, all right? Doesn't talk about architectural complexity and doesn't talk about why is optimized for. And that's our very important conversations we need to have. Now that we have these things in mind, let's talk about some approaches, all right, that we're gonna see on the industry. So actually, before talking about approaches, let's go back and talk about principles, right? And let's think about lean, agile, and DevOps principles, all right? So there's many lean, agile, DevOps principles, but I want to highlight on these ones because they're the ones I feel they have lots of relation with CICD, DevOps, and continuous integration. And there are, first, you want to increase the feedback on the system. You don't want to reduce the feedback on the system. So you want to get feedback faster. So whatever branching model you are doing, or no branches, all right, could be your branch strategy, you need to think, is that increasing or decreasing the feedback on the system, right? That's one principle we want to follow from Agile. The other principle is we want to reduce feedback cycles, right? We want to make feedback cycles to be smaller as possible, right? So right away as you type, you might want to have feedback from that, right? So is our branching strategy reducing that feedback cycle, or is it increasing it, right? Are we reducing batch size or we are increasing batch size? That's the delta problem. So when we do releases, it's best we do like a yearly release with like 1 year of changes and software. Lots of things can go wrong and will be hard to track what's wrong there, and to hold back it will be practically impossible, right? So what you want to do is you want to rely on the first two principles, increase feedback cycle and reduce feedback cycles, and you want to reduce your batch size. So when you deploy in production, you want to deploy on the smallest unit possible, all right? Because that means a lower delta. If it's a lower delta, if something goes wrong, you have a faster and better chance to figure out what's wrong and hold back just that change. So, high throughput companies, highly successful companies that are doing real DevOps and real CI/CD, they want to reduce the delta, right? And several companies, they do work with release calendars and release trains, and I'm gonna cover that later on. But what we need to think about it is that reducing feedback cycles, or is that fixing release cycles? Is that fixing batch sizes? All right. So we actually, I'm gonna go back to these principles later on, but we want to reduce the batch sizes. That's a question about risk, and we want to reduce risk. It's important to do smaller batch sizes. And what we need to think about it is our branching model reducing batch cycles or not. We also want to increase the development frequency as a side effect of reducing batch size, all right? And we want to experiment often, and that's like not only for software, but also for the business, all right? The business wants to do A/B testing and discovery. And for that reasons, you want to do more experiments, all right? It's all about experimentation and discovery. And what we really need to think about is these principles are gold, right? And what we need to think is, okay, is our branches aligned with that or not? So think about that. And now let's talk about some options that we're gonna see on the industry, right? The first one I wanna cover is called branch by abstraction. And basically, you can use that when you're gonna do technology migrations, right? So let's say that you're using Hibernate and you wanna go back to the JDBC, for instance. So this branch by abstraction is a sort of a long-lived branch, all right? So it easily can live for more than one sprint or 2 weeks, depending how big is your sprint, if it was 1, 2, 3, or 4 weeks or 6 weeks. So this can be even longer than a sprint. And the benefit you get by doing branch by abstraction is it's easy to pause, right? And it's easy to cancel, to run that project away. And how you do that? Well, first you introduce abstraction. So let's say you have your JDBC code. So you put an interface there and you make Hibernate the first implementation of that abstraction. Then you write the second implementation. It's going to be using JDBC. And then you enable it, right? And then you can even use feature flags, switch on, switch off, and then later on you can remove it. And that's how you do branch by abstraction, right? It helps a lot to do technology migrations. Or if you're going to do a big redesign, also might be a way to do it. So the second thing is called branch by release, and several companies do that, right? So the team pushes to production in a regular cadence, right? Every month or every sprint or in every quarter, whatever. And you also you need to push bug fixes, because bugs you might have like a P0 or P1 that might happen outside of your deployment cycle, let's say every 2 weeks, and you wanted to push that before the 2 weeks. You don't want to wait because your site is down or because that's critical for your business. You might be losing revenue. So a branch per release is a stable place where the devs are still committing on the trunk or the mainline, that could be main branch or master. And then you can, from that, you can cherry pick to the release branch, right? CICD teams do not do that. They release from the trunk, all right? But I want to talk about this practice. You need to know that exists, even though it's not the ideal approach you should be doing, right? Now, let's talk about release from the trunk, which is what CI/CD teams, they do, all right? So teams that have a high release cadence, they release multiple times a day, they release from the trunk. And this does not slow down releases by any means, all right? And you still can create branches retroactively if you need it, right? Let's say if you do at least one time a day, you still could benefit with that. So now let's talk about CI/CD, right? So CI, continuous integration, by definition, it is one single integration source, all right? Meaning your developers are checking their code and their testings on the same branch, wherever that branch is called, no matter if that branch is called develop, trunk, or main, or master, right? Often call it trunk, but nowadays could be something else. And if everybody's working on their own branch or their future branch all the time, and they have this long-lived branch, they're not being integrated. Even though if you have a Jenkins pointing out for each of their Jenkins repositories, all right, and sorry, the Git repositories, and you have a Jenkins job for each of those branches, they are not integrated, right? And they're only going to be integrated when you merge everybody. And if that only happens when you are about to release to production, that's bad, because you're not continuously integrated, right? So you are not doing CD at all. So CD, by definition, requires to have people working on the same branch, which is not what people do at all nowadays, right? And that's funny, because people don't do CI. They think they do CI just because they have Jenkins, all right, and just because they're building from branches, but they have so many feature branches there. and they want to do CD, but they're not doing CI at all right? And is not how it works at all. So that's the first thing we need to clarify here. All right. So trunk-based development is the way to go. It's high throughput, successful DevOps thing, what they do. So basically, I need to say that trunk-based development is incompatible with Git Flow. All right, and we're gonna talk more about Git Flow later on. But this, I just want to say that this is incompatible with Git Flow. So either you do Git Flow or you do trunk-based development. All right. So trunk-based development works for fast interactions, all right? So releases. And if you have seniors engineers, and basically you are releasing as as fast as you can. So you basically can cherry pick things from the trunk, but your all releases they happens from the trunk or the master or develop, whatever you call it. So now let's talk about Git Flow. So Git Flow, you have several branches. You have your master branch, but people work on develop branch. But actually, they don't work on develop branch. They work on future branches. And everybody might have multiple future branches, which are long-lived branches, all right? And then they might go back to develop. And then you create a release branch, and you even create hotfix branches. And this is very complicated, all right? And people develop tools and workflows so you can understand how this works. But this is really, really complex, all right? And I feel like it might make sense when your architecture is really bad. That happens in mobile, right, where you don't have much isolation at all. So people really love to do Git Flow. But really, this is complex as you get it. It's really, really complex. And you don't need that, right? And this also creates several issues, all right? Because you are not doing CI, and you actually gonna do less refactorings because try to merge these refactorings. You're gonna see it's really hard to merge it when everybody's doing refactor. So the side effect of that is people gonna do less refactorings, right? And they just gonna rely on branches. And I even would say that people tend to do less tests, right? And this hides bad architectures. So Git Flow is really complex. You should not use it at all. And also Git Flow create anti-patterns like commit traces, where there's lots of changes. Every engineer is doing lots of changes, and the first to commit it wins, so it doesn't need to do a merge. All right. So there is this rush to see whoever releases first, because that person doesn't need to do a merge. So let's highlight some of the issues we have with branches, all right? So they do not encourage refactoring because this is harder merges, and because everybody's looking in feature branches which are long-lived branches. What happens is people end up not doing refactoring at all right? Unless there's a explicit policy in your Kanban or your architect is driving that behavior. But otherwise, if nobody's doing anything, what you're gonna happen by default is less refactoring, which is bad. You also might have a shallow review problem, right? That it can be seen as LGTM. What happens is everybody's driving so many changes all the time, and people don't want to be, wasting time doing code review. And then you just get an LGTM in less than 1 minute, right? And then you're merged. So really, that's happening all the time, right? Why you're not doing trunk-based development, all right, with everybody together. You literally don't have any value doing pull requests and branches. That's just bureaucracy. You should remove that and just go trunk-based development, right? And that happens a lot. Batch size is also a problem here. We have something that's anti-lean. Easily your feature branch can be 2 sprints, 3 sprints, can be a quarter or even more, all right? And the problem is nothing is being integrated, all right? So you're creating a huge batch size, and that's anti-lean. You also don't have CI and real CI happening, all right? Because everybody's working on their feature branches. And also we need to think about this, all right? So sometimes there is 2 sorts of personas that gonna commit your repositories. So one persona is your core team members, all right? Your workmates. And the other personas might be somebody from another team, but still from your company, all right? It might be a contractor, might be a vendor, It might be a partner company, right? So let's call these guys external contributors. For external contributors, it makes sense to go to a PR and review with more rigidity. But for internal core members that you are working every day and you can change things easily and you can use other techniques like pair programming, like, different review cycles that are not based on the deltas, right? I personally always did reviews like every month or every 2 or 3 weeks, reviewing the whole code base, because I don't like to see deltas, because for me deltas, they don't tell me the big picture. Right, so I personally think like a PR review is very limiting, and that's a side effect you get from Git Flow. So literally, you need to think about this, all right? Who is sending the PR? Is your team or some external entity? So if it's an external entity from your team, it makes sense to go through that process. But for your team, do you think that makes sense? Do you think you are getting benefits on doing that? That's something you need to think about. I think often it's not really the case. So now, let's think about and let's talk about alternatives to branches, all right? So what high throughput DevOps teams they do is they work with forms of toggles. So you might have like operational toggles, permission toggles, experiment toggles, and release toggles, right? And basically that's one way to do it. Another way it might be doing abstractions, right? And with abstractions and toggles, you really have a way to control your code, right? So toggles are just like properties or variables that are on and off, and based on that we enable a code path or disable. It's really like having ifs on your code, saying, okay, if this variable is on, I'm gonna run this code, otherwise I won't run it, right? And there's plenty of tools that can help you to do that. If you also check out my blog or my YouTube channel, you're gonna see I also have videos when I talk about testing in production, and I have talking about tools in Java that can help you to do that. And there's plenty of tools for pretty much all languages. One other thing we need to cover is the issues with release trains or release calendars. So if you are delivering one time per quarter, one time per year, or less than that, right, you're pretty waterfall, release trains and calendar is going to be awesome for you, because now you're releasing every 2 weeks, but you need to continue pushing the bar, right? The problem is like people get sort of comfortable with release calendars and release trains, and they don't move from that, and they're always doing that, and they stay doing that forever. And then going back to the principles, they miss the point, because they're not increasing deployment frequency, they are not reducing batch size, therefore they are increasing risk. Although the risk might be smaller than it was on the past, it's still risk, right? So you want to reduce that, you want to keep pushing that to make it better, right? But unfortunately, what I see over and over in the company is that release trains or release calendars, they go there and they get stuck there, they don't move from there, and then they end up seeing CICD as just a tooling exercise to get better tooling, but they don't change their mindset. That's why it's important to talk about principles, and that's why we talk about principles, and we thought about dimensions and all these considerations about architecture, testing, refactoring, and so on and on. Now let's talk about Gitflow. So if you really want to do branches, right, I feel like that's the less painful way to do it, right, is to use GitHub Flow instead of a Gitflow, right, because it's much less overhead, is much more lightweight. Basically, you fork some repository and then you work in your trunk or master or develop or main, whatever one you call it, in your main branch, and that's it, right? So you just have one branch, you work on that, and you merge it back. And it's much more simple. You don't need any specialized tool. I still would argue that doing trunk-based development is better, but if you really, are not sure, or you want to start with this and then go trunk-based development, that will be much better. I would say use GitHub Flow. Do not use Git Flow, right? And you want to try to make this branch as short-lived as possible, all right? Now let's talk about Git Ops. So Git Ops is sort of a new way to do things nowadays, right? And it works with Kubernetes. So in Kubernetes, you have a YAML file that describes the cluster. And the good thing about that YAML file is that you version that YAML file. That YAML file is on Git. So you can easily review what's there, you can easily do rollbacks, and you can do PRs. And now PRs are great because all changes on the cluster in production, they go through a PR review, and you want to do that. All right, actually that's the time where PRs and branches are really, really good. But you don't want to mix Git Ops with Git Flow at all, because then you're gonna have something really complex. You need to do auto merges here and figure out deltas and stuff like that, and it will be really complex. You don't want to do that at all. I want to say, if you want to do Git Ops, either you do with trunk-based development or you do with GitHub Flow, right? And the whole idea of the Git Ops is like you have hooks on Git. So imagine like someone open a PR and that hook trigger a build, and that build builds the code, run the tests, deploy a test or a smoke test cluster in Kubernetes. Then you run all things, and if everything is okay, after the merge, you apply that change in production, right? And that's good because no changes happens on the cluster manually. All right, there's no SSH calls, there's no manual work. Everything is automated, everything is auditable, everything is rollbackable. You can time travel, you are PR friendly, you are dev friendly. So that's a very, very awesome pattern to use nowadays. Even if you don't use Kubernetes, I would argue that you can do a form of Git Ops, because you could use other declarative solutions like Terraform. Right? If you look like Terraform, you don't have a YAML, but you have TF files. And I would argue that TF files and YAML is the same in this case, because in Kubernetes you're gonna do kubectl, or you're gonna use Helm charts to apply that YAML change to your cluster, right? But with Terraform, you're gonna do Terraform apply, and you're gonna pass TF files. But the principle is the same. I would argue you can use Git Ops even with EC2 and Terraform, and that's really an interesting pattern to follow nowadays. I would argue that's the best pattern to follow, in the best way to apply change on the server, right? So now, if you think about PRs, pair programming, mob programming, code review, all right, we need to understand that PRs, they can create interruptions, because you are working on something, you need to stop what you're doing to deal with the PR, all right? Branches are really good for individuals, all right, but they're not that good for teams because of the interruptions and because they're not really CI. You're not doing continuous integrations if you're doing branches, right? So pair programming is code review. If you're doing pair programming, you don't need to do code review. You don't need to fire a PR, because pair programming is code review. That's something people don't get it, right? So there's no need to submit a PR if you're doing code review someone in your team, or you should be able to just merge it. So pair programming, mob programming, it helps to share knowledge across inside your team and across different teams. And pair programming and mobbing are much faster form of feedback, and they are aligned with the principles I stated before. So now let's talk about branches and architecture. So a good modular architecture would require much less branches or no branches at all. Right? Mobile might require branches by nature, because in the end everything is running on the same place, right? Although we have similar problem with front end, for instance, there are solutions that are trying to fix these problems. Like if you think about micro front ends or module federation, right? So it's all about architecture. As you get a better architecture, you have less needs to change on the same spots, and then you have more isolation. So isolation is the ultimate branch blast radius reducer, right? If you have everybody touching on the same thing, you might have a bigger blast radius, and that's why people want to protect themselves with branches, all right? But if you have proper isolation, proper architecture, by nature, architecture gonna be your brancher killer, all right? Architecture is gonna reduce the need of a branch. That's why when we talk about branches, we need to talk about in the context of your team, your architecture. We cannot see this blindly, all right? And sometimes what I don't like about this is just blindly following a branch model. It hides the architectural problems, right? And we need to bring these architectural problems up so we can fix them, right? And we also need to understand that code is dynamic and branches are static, right? So it's much better to deal with code like toggles, for instance, like dark canaries, right? And there's a whole video I made in a slide cast about testing production. I highly recommend you take a look, and I cover these things in more detail, right? But real and high performant DevOps teams, they are all about doing things dynamically and doing things with code instead of doing things with your SCM tool, right? So that's like one really important thing to keep in mind. So some wrapping up thoughts, all right? So branches in PR, they are cheap and they are the norm today thanks to Git and GitHub. Most of companies see CICD as tools, not as principles. So that's why you need to go back to the principles and understand these principles. It's common to see people that don't want to increase development frequency, all right, because they sort of improve from where they were, but now they don't want to take the risks. But that's important because staying where you are actually having risks. So you need to understand that not changing is increasing deltas, all right, and that's really increasing risk. So you need to understand complexity. You need to be complexity aware. All right, and that's important. Good architecture requires less or no branching, and branching could be hiding architectural problems and could also enforcing bad habits, as less refactoring and less testing as well. High frequency releases and Git Flow does not match. Please don't use Git Flow. Avoid Git Flow as much as you can for the complexity, for the commit haste problems. And lower delta, lower risks, release often, get more feedback is always better, right? It's always better, not only for the business perspective in sense of discover, but also in sense of the technical perspective in sense of reducing risk and rollback ability. So that's it. That's what I got for today. I hope you guys like it. See you next time. Take care. Cheers.